let us discuss about the computational graph. So what is a computational graph? It is defined as a directed graph where the nodes correspond to mathematical operations. Computational graphs are a way of expressing and evaluating a mathematical expression. So now, if you look into this figure, you can see two inputs, x and y, and the operation done over here is plus, and we have the output as p. So it is written as p is equal to x plus y. Yes, x plus y, right? So what are the steps to build a computational graph? There are only two steps. Step 1, build a graph. Step 2, execute the graph. So there are two steps, building and executing the graph. Now look at this. What do you understand from this? Do you get any idea about it? Just have a look at this image and tell me what is your understanding about it. Just think about it, right? You can see certain nodes over here, right? So here what happens is data flows from one node to another node. So we are talking about computational graph, right? So what is a graph? Graph is nothing but connected nodes. So here the data flows from one node to another. So in each node, we do mathematical operation. Say for example, here it has 2, right? Now this 2 is passed to node C, and here say we have plus 3. Now what will happen? 2 plus 3, which is equal to 5, right? So this is how it works. It is very simple. It is very simple to understand. It is not such a complicated concept. So this is how the process flows. This is how the data flows from one node to another node. So now let us understand what is forward pass. Okay, what is forward pass? Forward pass is the procedure for evaluating the value of the mathematical expression represented by computational graphs. Doing forward pass means we are passing the value from variables in forward direction from the left to the right where the output is. Now look into this. What we can see here is there are two inputs, 1 and 3. And here you can see the addition operator. So when these two inputs are passed, when the addition is performed on that, we will be getting the output as 1 plus 3 is equal to 4. So what is the value of P here? The value of P is 4. Here the X, Y and Z values are given, right? So from that only I have taken 1 and 3. Now look at this. Already we got this output, that is nothing but 4, and we know that the value of z is minus 3. So minus 3, here we use the multiplication operator. So this is 4 into minus 3, which gives us the output, that is g as minus 12. Hope this is clear to you, right? So 1 plus 3 is 4. The value of p is 4. And already we have z as minus 3. And we are performing multiplication on that. So 4 into minus 3 is equal to minus 12. So here we can see that g is equal to minus 12. Right? Hope this is pretty much clear to you. Now in the backward process, our intention is to compute the gradients for each input with respect to the final output. These gradients are essential for training the neural network using gradient descent. For example, we decide the following gradients: dou x by dou f, dou y by dou f, dou z by dou f. Right? So let us understand this in detail. So this is the thing we have seen in the previous slide, that uh, these two get added and we got P as 4 and this is minus 3, and when you multiply that we get answer as minus 12. So G is minus 12. If I perform dou G by dou G, what will be the answer now? Yes, you're right. It is equal to 1, right? So now if I find out dou G by dou Z, dou G by dou Z, what will be the answer now? So definitely that is going to be P. So basically I'm trying to differentiate G with respect to Z, right? So minus 12 and this is minus 3. So what is the value of P now? I can say that this is equal to, right? This is equal to 4, right? So similarly, let's find for dou G by dou P. So I'll give you 30 seconds. Can you please think about the answer? Exactly, right? So that is equal to minus 3, right? So that is what very clear to us now. So now what can we do? See, we have to find out dou G by dou X, right? So how can I find this? This is equal to dou G by dou P into dou P by dou X chain rule, right? Right. Similarly, if I try to get dou G by dou Y, dou G by dou Y, I can write it as dou G by dou P into dou P by dou Y, right? So just substitute the answers over here. Dou G by dou P is nothing but minus 3. And what is dou P by dou X, right? See, for example, so here we know that P is equal to what? X plus Y, right? We are supposed to find out dou P by dou X, right? So we know that P is equal to X plus Y. So that is what being carried out over here. So I'm writing dou P by dou X, right? So that's going to be 1 plus 0, which is nothing but 1. Yes. So now I know what is dou P by dou X. That is 1. I know this one. So that's going to be minus 3. Clear? Similarly, if I find out for this one, to find out dou P by dou Y. So when I find dou P by dou Y, again, this is going to be 1. So this is also dou G by dou P, right? So again, this is also going to be minus 3. Hope this is clear to you, right? So what are the steps we follow in this neural network? For data point X in dataset, forward pass with X as input and calculate the cost C as output. We do backward pass starting at C and calculate gradients for all nodes in the graph. This includes nodes that represent the neural network weights. We then update the weights by doing W equal to W minus learning rate into gradients. So we repeat this process until stop criteria is met. So hope this computational graph concept is very clear to you. Thank you.